Hello, everybody. This is Todd Menadier from the Rutgers Center for Mathematics, Science, and Computer Education. And I am in my home makerspace right now, and I'm going to talk to you a little bit about design challenges because we are going to provide these to you, and along with some solutions and hopefully some additional resources that you'll be able to explore later whenever this coronavirus thing subsides and we can all get back together and back to normal life. In the meantime, though, we have identified some problems called design challenges, and we are asking you to solve them in the most creative and inventive manner that you can. In the most cases, these can be solved with household items, and we will be giving you some solutions that will also be a little bit more difficult, but again, hopefully you can learn a little bit more about them either through videos that I supply or there's plenty of other resources out there as well. Um, Couple things about design challenges. It should be noted that there is no one correct solution to any of these challenges that we're giving you. There are an infinite number of solutions to them. And then the key thing that we want to do as we go through them is to follow what's called the engineering design. So, in order to solve our design challenges, we are going to be using the engineering design process. This is essentially just a problem solving method, and we're going to walk through it. If you Google it, you'll find that there are a number of different um, graphics that show up, and you'll see that all of them have the same kind of cyclical design to them because this is an iterative process. We're going to constantly go back, try to redesign and improve, hopefully improve upon the solutions that we have come up with. One thing that I want you to kind of keep in the back of your mind as we talk about this, and something that will kind of illustrate this idea and how important it is as we go through it, is your cell phone, right? So if you look back at the first cell phones, these kind of, if you know the reference, the Zach Morris cell phone, and then you realize how far we've come since then, you realize that they obviously followed this engineering design method. So what I did here was I used my experience, both as an engineer and as a teacher, to kind of take the best of everything that I saw available and put it into something that I thought would be a little bit more practical, something that anybody who's never designed or built anything before could use, plus something that's fairly, simple terms, simple words. And when we go through some of the design challenges, I will reference this again, and I'll talk about each step as we go through it too. So anytime you have a design challenge or following the engineering design process, the first thing that you're going to do is really try to figure out what the actual problem is. You're going to ask a lot of questions, and you're going to really want to define that problem the best that you possibly can. And this is not as easy as it sounds. For example, we're going to give you some design challenges, and when we do, we're going to state them in a variety of ways. And so each kind of manipulation on the way on the problem statement can actually have a different solution because they are slightly different problems that you're trying to solve. So regardless of what the problem is, you really have to know what the core problem that you're trying to solve is, and that right there is one of the hardest things that you can actually do, despite everything else seeming fairly challenging. After you know what the problem is, the next thing that you're going to do is you're going to brainstorm as many ideas as you possibly can. Okay, now that word here, imagine, is used in a lot of the engineering design process graphics that you'll find. And imagine is a very powerful word here because you are thinking of things that do not exist. You are using your imagination. You are not thinking of solutions that are already there. You're trying to come up with something that's totally new, totally different, and that's where the real learning comes in and the real inventions come in, if you will. And again, go back to that cell phone, right? Here's the problem. Define it as you will, right? I need to make a phone call and I don't have a phone nearby. I need to make a phone call when I'm in my car. I need to make a phone call while I'm walking down the street, right? Any one of those could be the actual problem that you're trying to solve. And then you have to imagine these solutions. Well, imagine I had a really long cord. Imagine I had a radio frequency portable one that had, further distance capabilities. Or imagine I could use this thing called cellular, which doesn't exist yet. So they had to imagine that in order to come up with it. Next, some of these graphics that you'll find, again, they skip this one for some reason, but I think that planning is really important because within your plan, you're going to have your materials list. You have to know what things you're going to need because you might have to purchase some things. You're going to have to know what tools you're going to need, and then what talent too, right? A lot of times we might not be able to solve these things on our own, or if you're collaborating with somebody else, then you have to decide who's going to do what and kind of break up the different steps that are going to be taken in order to solve this. And that's all part of your plan. Without a really good plan, without really having that preparation in place, it's going to be really challenging to do the next step, or any of the following steps for that matter, efficiently and effectively. So once you have your materials, you have your plan, the next step is essentially to prototype. Prototyping means that you're just going to take the bare minimum parts and make it so, and try to make it work. So by work, I mean you're going to take whatever you can to solve that problem, but it might not, for example, look pretty, right? It might have wires hanging out all over the place. It might not be the fastest thing if you're doing something related to computers, and speed is a requirement. If you're writing a process, a code, you might be able to speed it up later on, but the code might work in the meantime. So you're basically going to try to prototype it with whatever means you have as best as you possibly can, just to see if your ideas that you brainstormed actually work and function. Now, that's the next step, is to figure out, do they work, do they function? So you want to test it. And of course, testing can mean a number of different things depending on what the design challenge is, but you essentially want to put it through the most rigorous and most numerous tests that you possibly can, and then get feedback from your design. Does it work under these conditions? What if you change this? Then does it work better? Does it work worse? Test and evaluate and get the feedback from your prototype as much as you can. Use that feedback to create your redesign. Now, next to the redesign, I know my handwriting's hard to see here, but I got a little asterisk and a question mark where it says the word improve. Because you're going to redesign something, and you might have this great idea and you're going to redesign it and you think you're improving it, but when you go back around and you test and evaluate it again, you realize that was actually a step in the wrong direction, which is great though. It's often a very good learning experience. And of course, after you redesign and improve, you're going to recognize that there are other problems, other things that you need to identify. Maybe not the same problem. Sometimes you are going back to that initial problem. Sometimes you're recognizing that there are new problems. And then you kind of go through, and eventually, this is a circle, but eventually what it ends up being is this kind of swirl that goes down to a final end point where, and you can define that based on, your constraints for time, or the ability for the solution to actually solve the problem. Whatever it happens to be, you need to define an endpoint, right? We're not going to go around this circle a million times, but whatever that is, that's where we're all going to stop, obviously.